let's go over number 3 from the target round. And so we saying overall positive integers n greater than or equal to 2. What is the greatest possible value of the greatest common divisor of these two numbers? So we have 9 and then a bunch of zeros and 1. So n minus 2 zeros. So we can rewrite that as 9 times 10 to the power n minus 1 plus 1. Our second number here is n nines. So we can write that as 10 to the n minus 1. Okay, so to find the greatest common divisor, we can use the Euclidean algorithm, which tells us that if we have a greatest common divisor between, if we're trying to find the greatest common divisor between two numbers, it's the same as the greatest common divisor between the smaller number and the remainder we get when we divide the larger number by the smaller number. So let's try doing that. So our first step here is let's find the remainder when we divide our larger number, which is the second one, by our first number. So what we'll get is 10 to the n minus 1. We can subtract off one of these 9 times 10 to the n minus 1 plus 1, and that'll leave us with 10 to the n minus 1 minus 2. So it'll be 9s and then 8, right? That's what we get when we subtract 2. So we just simplified this greatest common divisor into these two new terms. So we have the first term is still the same, but now we're looking at the remainder. And so let's just apply this once more. So if we're looking at the remainder when we divide 9 times 10 to the n plus n minus 1 plus 1 by 10 to the n minus 1 minus 2, we can take out 9 factors, and then we'll have a remaining 19. So that can simplify this greatest common divisor into 19 and 10 to the n minus 1 minus 2. So when we're looking at the greatest common divisor between 19 and another number, it has to be a divisor of 19. So it's either 1 or 19. So let's see when it'll be equal to 19. So that'll only happen when our second term here, 10 to the n minus 1 minus 2, is divisible by 19. So let's see if we can find a value of n such that this number is divisible by 19. So in terms of mod 19, that means that this number 10 to the n minus 1 has to have a remainder of 2 when divided by 19. So we say that it's congruent to 2 mod 19. And so let's just multiply both sides by 10, and that'll get our left-hand side to be 10 to the n, and our right-hand side will be 20, which is congruent to 1 mod 19. And so we can find the value of n using Fermat's little theorem, which tells us that for a prime p, in this case, our prime is 19, we know that a number that's not divisible by that prime to the power of 1 less than the prime is congruent to 1 mod that prime. So in this case, we know that when n is equal to 18, we know that 10 to the 18 is congruent to 1 mod 19. And so that means that when n is equal to 18, the greatest common divisor between these two numbers is 19, and that's our greatest possible GCD of these two numbers. Yeah, so our answer is 19. All right.
Hi, everybody. This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.